solving equation of a circle with equation of a straight line. Let's, for sake of argument, I've got a circle equation of the circle. I'm creating x squared plus y squared equals 5. And I have a line with the equation y equals 2x plus 1. I want to know where this line and this circle meet. I need to find the coordinates of these 2 points. Let's say point A and point B. As you can see, the straight line is intersecting the circle at 2 points. The point A lies both on the circle and the line. Point B lies on the line and the circle. So I'm looking for a point that satisfies both equation of the circle and equation of the line. So that would be a simultaneous equation with one as equation of the circle and one the equation of a line. The solution of this equation give me the coordinates of A and B, the point of intersection of the line and the circle. Now, this is not the same type of equation that we did previously when we had crossing two lines. This is one non-linear and one linear. So we can't do elimination, we can do substitution. So to substitute, I go to the equation of the line, make either y or x the subject, and replace that in equation 1. Equation of the line already put in a beautiful form. Y is already made the subject. So I say from equation 2, y equals 2x plus 1. I don't need to make it the subject, it's already the subject. And sub y equals 2x plus 1 in equation 1. So here I'm replacing all y's, which is equal to 2x plus 1, in equation of the circle, which is equation 1. So I write equation 1 down. And I do what I've said. Substitute y as 2x plus 1. That the x squared doesn't need substituting. And y is 2x plus 1 to the power of 2 equals 5. I've got a bracket to the power of 2. That means you need to expand these brackets with 2x plus 1 in each. As a habit, I always expand the two brackets in a wider bracket, depending on what number is here waiting to be multiplied by every term inside. Of course, plus 1 does not change anything, but if that was a minus 1 or any other number, you can't remove the bracket unless you multiply this bracket inside. Let's go back to expanding the bracket. 2x times 2x That's 4x squared. 2x times plus 1. Plus 1 times 2x. And plus 1 times plus 1 equals 5. I simplify. 4x plus 1 equals 5. Now I'm going to remove the bracket. The number outside the bracket is plus invisible 1. So we have plus 1 times 4x squared, plus 1 times plus 4x, plus 1 times plus 1. I'm going to bring 5 to this side as well to form my quadratic equation. Simplifying, x squared and 4x squared, that's 5x squared, plus 4x minus 4. Now, we ended up with a quadratic equation. As you remember, there are 4 ways of solving a quadratic equation. First one was by factorization. I don't think this equation does factorize, so go straight to the formula. A is 5, B is 4 or plus 4, and C is minus 4. So I use the equation that you should memorize. Minus B plus and minus B squared minus 4AC divided by 2A. Remember, all substitution going to be done inside brackets. So we have minus B from here is 4 plus and minus B squared 4 squared minus 4 A 5 and C minus 4 divided by 2A. At this stage, you don't need to do any more calculation. You just enter that once with a plus sign and once with the minus sign into the calculator, and it gives you the values of the 2 values of x. But here, let me just show you how the calculation will work. 4 squared is 16. 4 times 5, 20. 20 times 4, 80 plus 80. Divided by 10. So x equals minus 4. Square root of 96 over 10. So 2 answers. I'll calculate this to 1 decimal place. X minus 4 plus root 96. And x is minus 4 minus root 96. I need to use a calculator. So we have minus 4 minus root 96. The answer divided by 10. To 1 decimal place, minus 1.4. And again, minus 4 minus root 96. The answer divided by 10. Give me, I think I've done that twice. Let me just check that again. Minus 4 plus root 96 divided by 10. That was for here. That's 0.6. So I found the 2x values. Now, I now need to find the corresponding y values. So we had 2 answers for x. We need to find the corresponding values of y for each value of x. when x equals 0.6, I can now use either equations, either that one or that one, to find the y value. Obviously, I'm going to use the easy one, y equals 2x plus 1, and I'm replacing x as 0.6. That is 1.2 plus 1 equal 2.2. So 1 point of intersection is 0.6 and 2.2, which that put me here. Both x and y are positive, so 0.6 and 2.2. To find this one, I use the fact that the other value of x is minus 1.4. When x equals minus 1.4, we know y is 2x plus 1 from the equation of the line. So y equals 2 lots of minus 1.4 plus 1. Minus 2.8 plus 1, y equals minus 1.8. Therefore, the other point would be x at minus 1.4 and y minus 1.8. That would be the coordinates of B. So that was A. That would be coordinates of B. Putting it on the diagram. So coordinates of B minus 1.4 minus 1.8. This is how we solve equation of a straight line with the equation of a circle, finding the 2 points of intersection created by the line and the circle. I hope you enjoyed your lesson. My aim is to make maths lessons enjoyable for you. I will give more examples on this topic. I hope you've enjoyed this lesson so far. Until next lesson, bye.